Hi, I'm Rob, N1NUG, and today I want to show you this KDK FM-240 2-meter transceiver that I picked up at a ham fest a few months back. Now, you may never have heard of the KDK radio company. It was sort of a small ham radio company that made some radios back maybe in the late 70s and 80s. Now, I've really only ever seen two models of KDK radios at ham fests, and one of them I bought about 10 years ago, and the other one is here on the bench. That's what we're going to look at today. Before we dig in and start using this radio, the first thing I want to do is clean it. It's actually kind of filthy. It was probably sitting around in someone's basement for a long time. So we'll get all that crud cleaned off. And I found the best way to do that is to use just diluted dish soap. You can see I've got some in a container here with some warm water, and I just use a rag and kind of go through it that way. I found this stuff works best because it's safe on the plastics, but it does have sort of degreasers, and it'll kind of break up and loosen up that dirt and grime that gets stuck in all those little crevices on radios, and especially in the knurls on the knobs and things like that. I've found other cleaners like Windex and Simple Green, things like that, are a little bit harsh on the plastic. They can sometimes discolor it, and they can even sometimes attack the silkscreen labeling that's on the front panel, and you'll start to remove lettering with some of those harsher chemicals. I didn't think of it until just now, but I should have done a before and after so you could have seen how filthy this radio really was. But it's all cleaned up now and ready to go. Now, this radio has a few unique features, as you might imagine. The first is that there's no built-in speaker, not on the bottom, and as you can see, not on the top. The only way that you can hear received audio from this radio is actually through the microphone. This actually works like a speaker mic. If I turn the squelch down, you can hear the static coming through. Now, you can also hook up an external speaker, so that's an option as well. But if you don't have one, the only way you're going to hear audio is if the microphone is plugged in. Now, if we look at the main tuning dial, we can see that the radio has 3 operations modes: VFO, memory, and call. Now, right now the radio is in VFO mode, and if you weren't sure by looking at the dial, you can see it printed on the screen there. And what that means is when you change the tuning control, it just increments the frequency. Now, we can also flip this over to memory mode, and you can see that we can now cycle through program the memory channels. The radio offers 16 of them. And then if we flip this over to call, we can go to a single call channel, which of course in this case is already programmed by the previous owner, to 146520. Now, this doesn't have to be a simplex frequency. It can be a repeater if you want it to be. I'm not sure if this is showing up in the camera or not, but some of these LCD segments are kind of fading in and out of visibility. I'm sure there's probably a loose connection in here. This radio is probably 40 years old after all. Anyway, the next unique feature on this radio is this QSY button up here. And what this is it's almost sort of like a temporary or scratch VFO that you can tune on the fly. So for instance, right now we are in memory mode and we are on channel 1, and the frequency programmed in is 145110. That's a repeater. But if I wanted to quickly tune in another frequency that I didn't necessarily have in memory or didn't want to set in my VFO, I could just click the QSY button, and what it does is it writes whatever is currently in memory or currently displayed into this kind of scratch pad QSY VFO, and then from here I can change the frequency. So if I just dial up to here, and then I can also change the offset if I want to. I can also change the CT/CSS tone if I want to. Now if I want to go back to where I was, I just push the QSY button again, and I'm back to channel 1. If I push this again, it toggles back to whatever I previously had in that QSY register. Now, one thing to keep in mind, though, is if I switch over to, say, VFO, or even if I dial in another memory channel in memory mode, and then push the QSY button again, it resets that QSY register and writes whatever we previously had in our operating mode to the QSY register. If I switch back over to VFO, you can see that when I turn the tuning control, it changes in 5 kilohertz increments, or this last digit over here. Now if I push the speed control, you can see that an icon lights up here, and now when I change the tuning control, it cycles in 10 kilohertz increments instead. I'm going to flip back up to memory mode, and then I'm going to push this button here labeled REV. This basically just reverses the transmit and receive frequency if you've got an offset enabled. If I push it again, it goes back to normal. The next button labeled offset changes the repeater offset from plus to minus to no offset. And to demonstrate that, I've got to go back to VFO mode for a minute. And you can see if I push the button, it changed the plus icon over to a negative. If I push it again, no icons are lit up, and that means there's no offset or we're in simplex mode. And then pushing it again enables the plus offset. If I flip back up to memory mode and then try to change the offset, you can see that nothing happens. It stays with whatever offset is programmed in that memory channel. And same thing for the call channel. If I try and change the offset there, I can't do it. This next button labeled speech enables sort of a talking voice inside the radio that will announce the frequency and different settings as you change them. Obviously, this radio doesn't have that feature, so this button is non-functional. The button labeled priority engages priority mode. If we push it, you can see the icon lights up here. Now, regardless of whether you're in VFO mode or memory mode, the radio will check the call channel every 5 seconds, and if there's any activity there, it'll switch over to that and stay there. If I want to turn off priority mode, I just push the button again and the icon disappears. Now, this radio does have a menu tree, and it's a little bit different whether you're in VFO mode or memory mode. Now, if I access it in memory mode by pushing the enter key, you can see that the first item is frequency. And what this will do is change the frequency of whatever is programmed in the current memory channel. If I push it again, we can change the transmit CT-CSS tone. You can see that one's set to 110.9, but I can cycle that to any of the normal CT-CSS tones. The next option changes the scan mode for this channel. You can see it's set to auto right now, but I can change it to carrier mode. I can change it to skip if I want to skip this channel, or if I cycle back around, I can change it to delay mode. I'm going to leave it on auto. The next option is to set the duplex mode. You can see right now it's set to up, or a positive offset. I can, of course, set this to off if I want this to be a simplex channel. I can also select down, of course, and then I can select CR05 mode, which is a little bit cryptic, but what this is basically for a non-standard offset. It sets the transmit frequency to whatever frequency is programmed in the next higher memory channel. So for example, if we were in memory channel 14 and I select CR05 mode, the transmit frequency for this memory channel, memory 14, will actually be whatever's programmed into memory slot 15. It's a little confusing, but it gives you a way to do a non-standard offset if you need to. Now, the next time I push the enter button, it's going to commit all of those changes to memory, and you'll hear a long beep come from the microphone. Operation of the menu system in VFO mode is similar to what it is in memory mode, but we have some different options. So if I push enter, you can see the first one is the scan limit. That sets the lower scan limit for the VFO. If I push it again, you can see it's scan high. That sets the high frequency scan limit for the VFO. And then I can also change the tone, the CT-CSS transmit tone, for the VFO register. And I can also change the scan mode just like I could in memory between auto, carrier, and delay mode. The next option allows us to change the tuning step. You can see by default it's set to 5 kilohertz, but I can change that as low as 2, or I can cycle it all the way up as much as 40. I'm going to set it back to 5. The next setting changes whether or not the tuning dial wraps around. So if you're at the highest frequency and you click one more time in that same direction, it'll go back to the lowest frequency. Or if you set it in stop mode, it won't do that. You'll tune up as high as it'll go, and then it won't tune any further. I like wrap mode, so I'm going to leave it there. And you heard by the long beep, that was the last setting in the menu for VFO mode. Now if I switch up to call channel mode, now if I push in on the enter key, you can see the first option is actually the receive frequency of the call channel. So we can do sort of a non-standard split with this by setting a receive frequency, and then if I push in on this again, that can set a separate transmit frequency. And then the last option in call mode is to set a transmit CT-CSS tone, and you heard the long beep, so that's it. Now up here on the top right above the microphone connector is this button labeled tone squelch. And basically what this does is when you push it in and enable it, it sets whatever frequency is programmed in for your transmit CTCSS tone and enables it for the receiver. And basically what that means is the receiver will stay muted until it hears that CTCSS tone on whatever transmission that it is receiving. If that tone isn't present, the receiver won't unmute. And then this last button changes the transmit power level between high and low. High power is 25 watts and low power is 5. And then right below those buttons there are two status LEDs. You can see if I turn the squelch down, the receive light lights up green when it receives a signal, and then the transmit light will turn red when I transmit. Now if I quickly unplug the mic, you can see that this is a standard 8-pin connector. Now this microphone may not be the original microphone that went with the KDK radio, I'm really not sure, but it is sort of a Kenwood style microphone. It's got the up and down controls, and it's got a keypad on the back, although the keypad doesn't seem functional with this radio. I can't use it to change the frequency, and even if I transmit, it doesn't produce a touch tone or anything like that. So that's why I think maybe this is not quite the right microphone that came with this radio, and the previous owner just used a Kenwood mic that happened to work with this radio. Not much to see on the back of the radio, just the heatsink here, that external speaker jack that I mentioned earlier, and obviously one of the previous owners of this radio changed out whatever stock power cord was here with an Anderson power pole pigtail. And then for an antenna connection, rather than having an SO239 mounted to the chassis, there is a short coax pigtail with the SO239 here. For an early 80s radio, this KDK was pretty feature-packed. It had to be a big deal back then, especially with the fact that it has the full CTCSS tone encode and decode sort of built into the radio. You didn't need to buy an add-on board, you didn't need to set dip switches, that kind of a thing. It was all fully integrated into the radio, and you can even set different tones for different memory slots. Another thing that's interesting about this radio for the time period, or even today in 2024, is the fact that it's pretty small. It's about 1.75 inches thick, it's about 5.5 inches wide, and I think it's about 7.75 inches deep, including the heatsink and the knobs. And that's pretty small, even by 2024 standards. Now, of course, as I mentioned earlier, the radio can only put out 25 watts. It can't do the full 50 that we're kind of used to today. But for a radio with a non-detachable face, this has got to be smaller than most of the radios on the market today in 2024. Now, two things that contribute to the small size are the fact that the radio has no speaker. We have to either use an external speaker or live with the speaker mic setup. And the radio only puts out 25 watts. If it were 50 watts, which is sort of what the standard is today in 2024, the heatsink and chassis would probably be much bigger. The difference between 50 and 25 watts is really only half an S unit at the receive station. So I'm not sure we're really missing out on anything by losing that extra 25 watts. Having said all that, what I think I want to do now is try the radio out. I've tested it from a basic level. It obviously turns on, it transmits and it receives, but beyond that, I'm not sure how well it actually works. So let's dig in and find out together. Let's start off with a power output test. I've got the meter set to 200 watt mode so we can check high power, and that means for right now we're going to measure along this sort of middle range on the meter. I'm not sure how accurate this meter really is, but you can see that we're measuring somewhere maybe around 23 watts or so, which is probably within spec for this radio. If I switch over to low power mode, I'm going to set the meter over to 5 watts, which means we're going to measure on this lowest scale now. Now again, I'm not sure how accurate the meter is, but you can see we're getting pretty close to 5 watts. So I think we're within spec for the radio, and the meter for that matter. For the next test, I'm going to leave the radio set up over here on the dummy load, and I'm going to set up my software-defined receiver on my computer, which is behind you, and I'm going to transmit on the radio and let you hear what it sounds like on the SDR. This is N1 NUG testing the KDK FM-240 on 2 meters. Now, it looks to me like the radio is off frequency a little bit. I've got it tuned right to 146520, but according to the SDR, it's showing low in frequency. I set the tuning step on the radio to 2 kilohertz, and I've tuned up to 146,527, and now, according to the SDR, it looks like we're on 146,520. So it looks like the radio is going to need a little bit of an alignment and adjustment, but it does seem to be transmitting and putting out decent audio. Next, let's do a couple of quick receive tests. First, I'm going to head out in the yard with my HT. We'll do a quick transmission and make sure that the receiver is doing what it's supposed to do with a strong signal. If that seems like it's in line, I'll tune around and see if we can find anything on a local repeater to listen to and see what that sounds like. This is N1 NUG testing the receive capabilities of the KDK. It seems like the receiver is on frequency and receiving signals just fine.
Let's start at the top here. KB10YB, good evening, John. KC1, KWX, good evening, Chris from Tolland. K1MAL, good evening, Chris from Waterbury. KB1FQS, good evening, Eddie from Berlin. KC1JTS, good evening, Bill from Windsor. KC1UNN, good evening, Alfredo from Feeding Hills. And W1 Sierra Delta Sierra, good evening, Scott from Vernon. Any corrections, please let me know.
Based on our tests, it looks like the receiver is working okay on the radio, but the transmitter is off frequency by about 7 kilohertz. Now, I'm going to assume that's due to aging parts in there, capacitors, resistors, changing value over time as their material properties change. Now, usually there should be some kind of adjustment in here to tune the VCO and get it back on frequency. Now, because this radio is fairly rare, I don't think we're going to have any luck finding a service manual or let alone any kind of a schematic for this thing to help me figure out where that VCO tuning control might be. So I think I'll pop the cover off and just look around. Maybe we'll get lucky and the designers labeled the silk screen on the circuit board or something. I've obviously pulled the covers off the radio and we're taking a look inside. This is the top of the radio and I've kind of scanned it and it doesn't look like there's anything in here that would be pertinent to the VCO. So I'm going to flip it over and look at the bottom side. Now if we look down here, we've got this shielded area and a lot of times the oscillator is going to be located in there. Now unfortunately it looks like we've got pretty decent build quality here and the cover of this shield is soldered on. However, there is one access point here that's full of wax and I think there's an adjustment under there. So if we kind of pull this wax up out of the way, we can see a control down in there. Now the fact that the wax popped out of there so easily and so perfectly tells me that a previous owner has probably been in here and fiddled with this thing. I should have some sort of a frequency counter or a scope to really dial this thing in. But what I'm going to just try and do is make a very small adjustment to this and then keep an eye on the SDR while I'm transmitting and see if the frequency changes. We should be able to get it close enough with that method. I'm not seeing the frequency change at all, although when I put this in here, I can start to see harmonics appear on the SDR. So we're obviously affecting something, but not the transmit frequency. I'm reluctant to start trying to screw around with some of these other controls. There's a couple variable resistors and variable capacitors here. I don't think they have anything to do with the transmit frequency. I think these are all for tuning other parts of the circuit. So I'm going to leave those alone and assume that I need to pull this cover off and get at something else in here in order to fix the transmit frequency. But without a schematic or a service manual, I really can't be sure. Unfortunately, I wasn't able to adjust the transmit frequency. I did look around online for at least a schematic, and I came up empty. The only thing I was able to find was a user manual. If you happen to have a schematic or a service manual for this radio, send me an email or some other kind of private message, and we'll try and work something out. I'd love to get this radio going. Now, before I make the radio worse, I think I'm going to wait until I have proper documentation or maybe get a hold of another radio that needs parts or something and make one good radio out of two. Something like that. Either way, it's going to go in the project pile for now, and I'm going to move on to something else. I hope you enjoyed the video. Thanks for watching.